Frustum and occlusion culling. When the engine renders an image, it utilizes various optimizations to speed things up. One of those is Frustum culling, which aims to exclude objects from the rendering process which are outside the camera's field of view. There are several engine features that we can use to get an insight into what is going on behind the scenes. Most of those features are toggled through CVARs. The first thing to be aware of is that you can enable different stats overlays. For example, if you enable spatial.culling.showStats, the engine prints how many objects it tested and how many passed the test. So up here we can see that the number of passing objects changes as we move the camera around. But we can also visualize what objects the engine would render from a certain point of view. To do so, we add a new game object to the scene and attach a camera component. Then we set its usage hint to culling. This tells the engine that this camera could be used for culling only. When the camera object is selected, the editor shows a preview in the top left corner of what this camera can see. Additionally, we have to enable the culling debug view through the CVAR spatial.culling.vis. As we can see, the engine now only renders the objects that are visible from the culling camera's perspective. This also broke lighting, because the lighting information is now computed from a different perspective than from where the editor camera looks into the scene. We can simply switch the render mode to diffuse color, since we don't need lighting anyway. Now, as we move the culling camera around, we can observe what the engine actually renders. And as you can see, it renders many objects that are occluded by big walls and therefore cannot be visible from this position. Fortunately, ezEngine supports occlusion culling, which allows us to set up dedicated occluders, which are then used to quickly reject objects. In this sample, I have a prefab for the walls. In this prefab, I add an occluder component, which covers the entire wall. Now in the scene, I see a significant difference. I can also toggle the CVAR spatial.occlusion.enable to compare. If we additionally enable the culling stats, we can see that the occlusion culling rejects a large number of objects. Finally, you can enable a preview of the occlusion buffer. This displays all the occluders that were used. Since rasterizing the occlusion buffer itself also costs performance, you should make sure to only have occluders that are necessary. For example, here we do not have occluders for the floor and ceiling. Be aware that gray box geometry is automatically used as occluders, which is typically very useful, but can also add too much detail. So check the occluder preview to see where unnecessary occluders can be removed.